Hello, my name is Jan Infinity, and this is Physics Lab 5, Energy versus Momentum. Alright, so the purpose of this lab is to determine the final velocity of an object using two completely different methods, the energy principle and the momentum principle. This experiment was chosen because all values stay constant. Theoretically, using either principle, it will give you the same correct answer. Alright, so for my models, I use the energy principle. For this one, I did the simplified version, so delta K, no change in kinetic energy equals work. Also use the momentum principle, which is this one I have the velocity update formula. So final velocity equals initial velocity plus F net over mass times delta T. Also have the kinematic equation that we use right there, and then a work equation, which work equals force times delta R, and then uh, acceleration for this will be F net over m, but in this case we use gravity as the acceleration. Alright, so for the experiment, a baseball with mass m equals 0.142 kilograms was rolled off a ledge with a height of h equals 0.92 meters with an initial velocity of 2 meters per second in the x direction. We first need to find the distance d that the ball traveled before the ground, which is what we can use tracker for. Using these variables above along the video, we can calculate the final velocity in the baseball two different ways. Alright, so this is my video I have right here. I'm just gonna roll a baseball off. I calculated the force that I applied, and with it I got 2 meters per second approximately. And after putting it into tracker, I tracked the exact point where the baseball hit the ground, and I measured that using the calibration stick. I got 1.16 meters for the D. Alright, and this is my work right here for the results. So part one, I calculated the work for it using the equations d and h for distance and height. After getting that, it basically just simplified to mass times gravity times h, which is potential energy, which just gives you 1.28 joules. Alright, then part two, I split this the energy principle, try to calculate the final velocity. Right here, I used my initial and final stuff. I basically did the energy principle of changing kinetic energy equals the work, and just solve for final velocity, and I got 4.69 meters per second. And then for part three, I did the same thing using the momentum principle, which took a little bit more work and more steps. I used the kinematic equation found in the models, and I solved for delta t. Delta t equals the square root of, I believe, 2 times the height over gravity. And then taking that, I plugged that delta t into the momentum principle equation, which right here is the velocity update rendition of it. And I solved for final velocity, and after that, I got the vector of the final velocity. And after going for the magnitude, I got exactly 4.69 meters per second, which is the exact same I got in the energy principle calculations in part two. So I got the same final velocity at either time. Alright, so in conclusion, in short, you can find the final velocity of an object using either the energy principle or the momentum principle. The two methods utilize the same knowns combined with different equations and supporting variables equal the exact same value. To improve the procedure for a future experiment, having either finer precision with the video recording is crucial. Lining up the eye of the camera with the same plan as the baseball results in a distance result from the tracker that is close to the actual result. And additionally, with the initial velocity, making sure it's approximately 2 meters per second every single time, and that is caused by human error, of course. I try to get as close to 2 meters per second as possible from what I remember from my testing, but it was about approximately. It could have been a little bit more, it could have been a little less, but preferably what you can do is without human error is like have a piston or some sort pushing it off at exactly 2 meters per second after the applied force. That is my Physics Lab 5. Thank you so much for watching. Bye bye.